And in this session, I will try to show you that there is no way around it. Without automation and without enabling unsupervised machining, which means no operator at the machine, this industry is going to face headwinds, and some people may go out of business. Now, the reason for this is that one of the biggest trends that this industry is experiencing is a lack of skilled workforce. There's a shortage of people, there is a shortage of skills. Here are just two numbers to demonstrate to you how acute the problem is. So 50% of machine tool manufacturers are already dealing with labor shortages in Europe, and I personally heard the same feedback from other regions. And 30% of these people believe that this problem will become worse as we go on. We can see two major reasons for this. One is the short term, and actually here the corona is to blame, because after a big slowdown during the corona, after pandemic, a very strong rebound caught people unprepared. So people left, but they didn't come back to work. People stopped manufacturing, and now they had to catch up. This was really a big shock to a lot of industries. Actually, the second reason is much more concerning, because of the societal and demographic changes. We see that there are fewer people going in, let's call it, traditional machining industry. And as the result, we see a rising labor cost in order to attract talent and skilled people and retain them. There is, related to this, this societal change, is the fact that people nowadays, they are coming to work and they're not staying in the same workplace till their retirement. If you go back 30, 40 years, people were joining the company and they were staying there for 30, 40 years till they retire. Not anymore. We see people switching jobs every few years, and this is only going to increase this workforce mobility. So this means that now companies must invest much more effort and money to recruit and retain people, and the statistics is actually staggering. So 24 months, 2 years salary to replace one capable employee, a huge, huge cost. So let's consider the implications of these two trends that we saw. Fewer people going to the industry, higher turnover, higher cost to recruit people. Now, the first approach to deal with this trend, to deal with this challenge, is pretty obvious, and it's the topic of our discussion today. Automate more and get rid of the people, or not be reliant on the people as much as you have been before. And here we can see a robot that loads the blank, starts the NC program, and once the NC program stops running, it unloads the finished part. So it runs completely autonomous, no need an operator in front of the machine. I can give you one example from a factory that I visited in Germany. I was working with the production manager on the shop floor, and they have completely identical machines. So there's like around 20 machines in the hall, and in front of one machine there was a huge robot, and a very complex one with a lot of cameras, because they had to position the parts very precisely, and very big, very expensive, and very, very slow. And next to it, there was a machine on which the operator was loading and unloading the parts. I actually measured, and the time that it took the robot to load one part is 3 times longer than it took the operator to load exactly the same part into exactly identical machine. So I asked this manager, why do you bother? I mean, why do you have to invest so much money when a human makes this job It's quite a simple job, much faster. And he went ballistic. He started complaining that the people that come to work, they have hard time recruiting them. And so they have to use agencies. When they use agencies, they send them people that show up for the job one day and the next day simply disappear. They have people that don't have any skills. So the moment the job becomes a little bit more complex, they fail. And this robot, even though it's much slower, was their solution to the problem of dealing with unskilled and missing workforce. So here's one example where already we're seeing an impact of this trend in this case in Germany. Now, in reality, what we also talking dual challenge. We're talking about shortage of skilled workforce. So automation and unsupervised machining is an answer to the shortage. Now, what happens with the second challenge of skilled people? And the answer is that we see additional shift in the industry. If we want to use people that are not highly skilled, or we want to make people productive quickly without investing heavily in their training, this means that we need to use applications and solutions that are very easy to use. Or in other words, we need to have solutions that are intuitive to use. Because if a product or a piece of equipment is very complex to operate, then unskilled people or not highly skilled people will have hard time to operate it correctly, and this will lead to additional cost, expensive production delays, and whatnot. If the equipment is expensive and you need a skilled people, then once the skilled person leaves, then it will be very costly and very long effort. You remember this 24 months salary to replace one worker, right? It will be very expensive to replace such a person. In either case, if you want to use automation, it must be easy to use. So even unskilled people or not highly skilled people can operate it efficiently. Because otherwise, you'll have incidents, accidents, and the costs are going to be high. Now, look at this. This is a breakage monitoring system. And when you look at this, think for yourself, can you quickly decide which waveform is right to use for which tool, for which type of material, and for whatever geometry you are now cutting? I find it very non-intuitive and very complex. So in the quest to overcome lack of skills, this type of product is too complex. And to give you a related example, in a factory in the States, I was talking to one of the technologists, and they said that the only thing that they trust their operators to do is cycle start and reset buttons. That's it, nothing else. Everything else they considered too complex for the level of skills they had on the shop floor. Now think about putting such application in front of the operator, which is only trusted to do cycle start and reset. Let's go back to the automation. So we said automation is one answer to the shortage of skilled people, shortage of people, and easy to use is the answer. Automation that is easy to use is the answer to the lack of skills. When we are talking about automation and supervised machining, let's say we implement them as to address the challenge of workforce shortages, they actually introduce additional challenges. Now, the first one is tool breakages. And why is it a big problem that the tool breaks when operator is not there? There are three reasons. The first one, undetected breakages are expensive. because they lead to production delays, they lead to scrap parts that have to be thrown away, money wasted. They also lead to warranty costs. Because if you accidentally ship a faulty part, let's say you ship an engine block without oil channels, and then this engine overheats and blows up, the manufacturer of this engine block will have to pay tens of thousands of euros or dollars in warranty costs. Expensive. The second challenge with breakage detection is that it's not easy to do. So people use expensive laser systems, they use mechanical probes to overcome the challenge of breakage detection. And so this is a level of automation, but this introduces additional complexity because these systems can also break. And they actually slow down the process, because if I have to measure my tool every time they use, I'm adding seconds and more to my process. I'm reducing the throughput of my factory. So it's a very hard problem to solve. And even if you put additional system, then you're increasing your costs again. And the third challenge with real-time tool breakage is that if it's not reliable, if it generates too many false alarms, and by false alarms here we mean that the breakage alarm is generated, but there is no breakage, or vice versa, there is a breakage but no alarm is generated, then the costs of this automation are rising quickly. Because either you're losing throughput, you get a false alarm, the machine stops, and something has to be done, or you throw away a perfectly good tool, so you're increasing the cost of your cutting tools. Or even worse, you may need a human to review all these alarms. Now, if you need a person to supervise the automation, then what's the point of trying to remove the human from the loop? You're kind of defeating your own purpose. So unreliable tool breakage detection is wasteful, and it's one of the challenges when you introduce automation. Now, let's assume for a moment that you already solved the challenge of reliable breakage detection, everything fine. You know, once you detect the breakage, it's always reliable 100%. You have another problem. Because if the tool breaks, this means that something already went wrong. Actually, what you want is to avoid these breakages. You want to avoid anomalies that lead to expenses, that lead to wastage and something else, or costly damages. So what you want is actually to avoid anomalies. You want to have a very stable process, a very repeatable process. Now, why it's important to avoid anomalies? You can say, okay, when my tools break, I replace them. So what? But in reality, the situation is much more complex, because when there is an anomaly, it's not necessarily a breakage. It can be very high load, for example, on the tool. It can be some signal that exceeds certain thresholds. So when you detect an anomaly, you have to decide what to do with it. You have to devise ways to cope with it. If I detected something bad, what do I do? Do I rework the part now again? Do I send it for extra quality check, surface quality check? Do I throw it away? In any case, you have to design actions to handle detected anomalies. And this adds complexity and risk. Now, if you're already adding additional procedures, that you are adding additional steps to your process. So on one hand, you introduce automation to remove the people, but on the other hand, you made your process much, much slower, and that's what actually happened in case of Tesla. So anomalies that are not avoided, anomalies that you have to address, are adding cost, manufacturing cost. So in an ideal situation, when you're working with automation and you don't have operators at the machine, you want to do two things. First, you want to avoid anomalies. And if you cannot avoid anomalies, then at least you can detect them reliably. In this case, tool breakage. Let's see now a short video that summarizes these challenges and answers, or challenges and how to address them in around 60 seconds.
We always want the production process to run as smoothly as this one. But this is not always possible. Under pressure to deliver on time, We know you can't have an operator in front of every machine to prevent scrap parts. Besides, there are not enough skilled people to hire. You can avoid scrap parts and increase machine throughput without time and resource-consuming investments. Real-time detection of broken tools, combined with adaptive control, reduces your losses and increases your revenue quickly. This is possible without disrupting the production. Thanks to ACM Suite, you can reduce tool breakage and increase machine throughput and reliably detect breakage of small tools. Importantly, you can achieve these goals without making any changes to your NC programs or requiring more machine operators. Adaptive control not only improves the machine throughput, it also automatically detects and mitigates abnormal cutting conditions before they cause cutting tools to break. Used together with real-time tool breakage detection, you improve revenue and cut costs.
Okay. So now let's try to summarize everything that we just talked about. Actually, I talked about in one slide, kind of a flow chart. So we said that the first challenge is lack of skilled workforce. This is a trend in the industry, and it's only going to get worse. The answer is to have solutions that take the human out of the loop. So you're manufacturing without people, and you also have applications or solutions that are easy to use because it's a problem to retain and train highly skilled people. Now, the moment you take the human out of the loop, this means that you introduce automation, but automation in its turn introduces additional challenges. This means that you need real-time monitoring and control of all the robots and all these automated processes. You also need, and you see here it's in gray, remote monitoring control, because either you're at the machine monitoring it, so you're next to the robot, or you are away. And if you're away, you still need to be able to monitor the processes, and you also need means to automatically load and unload blanks and workpieces in and out of the machine. But these two are outside the scope of today's learning bite. Now, when you're talking about real-time monitoring and control, you actually have another challenge. You need to be able to reliably handle unexpected events. You need to handle it in real time. And as I mentioned, the answer is, first of all, reliable breakage detection. So if something went wrong, you can detect it quickly and reliably without false alarms. But you also want to avoid anomalies as much as possible, anomalies that lead to the tool breakages. So this is kind of a short flow chart of a challenge, an answer to the challenge, additional challenges that introduced, and eventually a solution. And in case of MACHINUM, the two products that you saw in the video is one, analyze my workpiece tool monitor for reliable tool breakage, and optimize my machining adaptive control for anomaly avoidance. Now, these are not the only products in our portfolio in MACHINUM that address the challenges of unsupervised machining and automation. There are additional products, analyze my workpiece monitor and protect my machine 3D twin, but they're not part of today's discussions, and we will discuss the use cases for these products in later learning bites. This is the last slide. So as Gokchi promised, it was within 20 minutes. What we saw today, that the industry has a challenge of recruiting and retaining people, and this forces the industry to invest in automation and unsupervised machining, despite all the challenges that are related to this process. And if manufacturers want to go further, if they want to endure in the industry and not go out of business, they simply don't have a choice. They must introduce more automation. They must think about manufacturing without operators in front of the machine. And to help machine users to cope with these challenges, we have products within the machining portfolio that allow them to effectively and efficiently implement automation and get operators away from the machines. We focus today on ACM, but these are not the only products in the portfolio that focus on enabling automation and unsupervised machining, and these These we will cover in the future meetings. That's it. Thank you very much for your attention.